So I'm going to spend a little time here talking about invasive plants in general, and then we'll talk a little bit more specifically about roadsides. But before I even go into that, I really want to define the terms because there's sort of two ways in which you can define invasive plants. One is more of a political way, and that's this one right here, and then there's more of a scientific way. So I just want to be clear on this as we go through it. So if you look at any kind of political definition, this happens to be the executive order through the U.S. government that was signed in 1999, and they define an invasive plant as a species that is non-native to an ecosystem that's under consideration and whose introduction causes or is likely to cause economic or ecological damage or health damage. So that accepts the idea that all invasive species cause harm, which you're going to see in a while is not necessarily what the way a scientist would interpret that. So, but it doesn't mean that all plants are invasive species if they cause harm. So, for example, this is poison oak, and I'm sure a lot of you know this. You probably know it all too intimately. At least I do. And but this is not something that I would consider an invasive species. It's native to habitats that we see. And say my voice is coming in and out, fading in and out. I hope that's not the case. Anyway, so we're not talking about these particular species that might cause human damage, but we're human harm, health effects, or something and whatnot. But I'm talking about species that are non-native in this particular case. And the non-native species we're talking about can have all kinds of impacts. Sandra talked about the impacts of roads on wildlife. I'll talk a little bit about the impacts of invasive species on human activities first, and most of it is related to livestock production. So you can lower, forage quality, forage quantity. It can interfere with grazing, particularly the spiny species can interfere with grazing. It can compromise livestock, horses, or human health. Poisonous plants would do this, of course. And then just the cost of managing these things can be a significant economic impact. Some plants can slow animal weight gain. Others can reduce the quality of the product, whether it be meat, milk, wool. And then aside from the livestock industry, invasive plants can impede recreational activities, and that can certainly apply to many wildland areas. And they can reduce land values. So and there's actually more than this. I just wanted to give you sort of an overview of the type of impacts that invasive plants can cause related to human activities and human values. But they can also impact wildland or ecological systems, and Sandra mentioned this, including wildlife forage and wildlife habitat, and then also just the biodiversity of the area, and that includes biodiversity of plants, of animals, of insects, of all kinds of things. And certainly this is very important when you talk about endangered species. So these are the types of things that they can impact. Now, I mentioned to you that there's a political definition, and there's also scientific definition. So when you look at the scientific definitions of invasive species, before we even get to invasive species, we have about 1,500 species in California alone that are non-native and that have become established. And so you might say, well, not all of them cause problems. So we use the definition of naturalized species, and these are non-native species that have been able to overcome various survival or reproductive barriers. And they really do not need any kind of human intervention. They don't need you to fertilize them, don't need you to water them, and they can survive for fairly long periods of time. Arbitrarily, 25 years was chosen. And so these are the types of species that are on their own. They've escaped cultivation, or they've been accidentally introduced, and they can survive. So these are not all problematic. There's a lot of these species in California, like I say, 1,500 of them. The next level would be invasive species, and so actually you would define an invasive species as basically a naturalized species that's capable of spreading. So it's able to move from wherever site it first got established, and it's able to do this on its own. So this definition, however, does not imply at all that these plants cause any significant ecological or economic damage. And this is where the political definition, differs from the scientific definition. There's a lot of plants that fall into the definition of really, or they aren't really on our radar screen in terms of managing them. So you say, all right, well, how do you define then the real problems of these species? What do they do that are different than just a plant that is capable of moving? And so we define these as mainly the transformer species. And sometimes people call these landscape engineers, but transformer species is the name I typically use. And these are invasive species that actually change the character, the condition, or the form or nature of the ecosystem that they're in over a large area. And so these are the ones that cause significant economic and ecological damage. So the political definition of invasive species would be more the scientific definition of the transformer species. And so I just want to make that clear so we recognize that there's differences among species that are the non-native species that are out there. There's 1,500 non-native species, and of the transformer species, there's maybe 200 in California. So it's just a small subset of the total number of non-native species that have become established. So how do you transform a landscape? Well, there's lots of different ways. Not all of them apply to roadsides. But just to go through them briefly, you can be an excessive user of a resource, and that resource can be light, can be water, can be gases. Aquatic plants, for example, can be excessive users of oxygen, and they can deplete oxygen in the water supply and cause massive fish kills. So that might be an example of that. You can actually be a donor of a limited resource. For example, many areas around the state have low nitrogen, or native plants have adapted to low nitrogen. And they don't do well when there's high nitrogen. So when you have plants, particularly members of the pea family, the legume family, move in and they fix nitrogen, they add nitrogen to the system. This allows other species then that like high nitrogen to move in. It makes it very difficult for native plants then to compete. One of the most common ones is fire promoters. We don't have too many fire suppressors here in the western United States, but we have fire promoters. I'm going to show you an example of this. More specialized types of transformers would be sand stabilizers. This usually happens along the coast. European beach grass would be an example of this. Another specialized one is a colonizer of the intertidal mud flats, and that might be something like Spartina, which also occurs in estuaries along the western coast. And then we can have plants that are litter accumulators. They act as mulches that prevent other plants from growing, or they can be salt accumulators or even heavy metal accumulators, so that they change the system such that only salt-loving plants can grow there, and salt cedar would be like this. So not all of these would apply to roadsides. Sandra showed a picture of kudzu. Here's a more dramatic kudzu shot for you. This is from the south in Georgia. Kudzu is one of these vines that was introduced intentionally as a forage species, but once it hit the forested areas, it climbed up trees, and it's an excessive user of light. So it basically blocks all light from penetrating into the canopy. Everything below it dies. So that would be an example of an excessive user of a resource. And it's mainly the poster child for that. And then a lot of the broom species would be examples of addition of nitrogen. So you'd get French broom and Scotch broom, Spanish broom, Portuguese broom, all of these. They all fix nitrogen. They all add nitrogen to the system. And then when they do that, a lot of other ruderal species or weedier species that like high nitrogen move into the system. Makes it very difficult for native plants to compete. But probably the most common one in the western United States is the fire promoters. The main one of these would be teak grass or downy brome, which is Bromus tectorum. Probably a lot of you are well aware of this particular species since it occupies about 56 million acres in the western United States. And when this species was introduced, and some people think it was introduced intentionally as food for travelers moving west, and others think it was introduced accidentally. Fires because they didn't have a lot of fuel to continue to carry that fire. So when these annual grasses came in, you can see just in this photo, they just filled in all the gaps, and they over a large area. And then when you had fires starting either accidentally or intentionally, they would burn for large acreages. In fact, not that particularly uncommon now to have a 1-million-acre fire in some of these states that are in the northern states where there's a lot of cheatgrass. So this really changed the landscape because the fire frequency or the fire intervals changed from once every 50 to 100 years down to once every 3 to 5 years. And the shrubs just can't compete with that type of fire frequency interval. They just can't even get to reproductive maturity. So it just takes a couple of fires and the shrubs are eliminated, and pretty soon you end up with landscapes that look a lot like this, which are just dominated by annual grasses. And of course, these annual grasses, they like fire, and they create a situation in which fire will actually select for them. So that's a major landscape transformer. Probably more area of the West is transformed by fire than any other of the mechanisms that I showed you. Medusa head would be very similar to that. Medusa head not only is a fire promoter, but it's also a mulch. It's a litter accumulator. It has about 10 to 14% silica. Silica is within glass, and so it doesn't break down very quickly, and it forms a mulch. And mulch is what you use in your garden to prevent weeds from coming in. So it's a strategy by which this plant suppresses other plants. You can also have plants like yellow star thistle here that not only are excess users of resources, and water would be the one that they use, but they also promote erosion. And the way they do this is, if you think about, our historic landscapes are primarily dominated, at least the foothills and the grasslands are primarily dominated by perennial grasses and then later by annual grasses. But grasses have most of their vegetation very close to the soil surface. I mean, that's why you grow a lawn, you mow a lawn, vegetation is close to the soil surface. So on a sloped area, when you had heavy rains, instead of the water just rolling down the hill, it would be intercepted by the vegetation of these grasses and would slow down the movement of water. And that would do two things that were very important in these areas. One, it would increase the time that water has to percolate into the soil, so it would recharge that water. And second, it would prevent sedimentation from moving off of the site because it would block that movement of water. So then these broadleaf species, yellow star thistle being the most common one in the state of California, when they moved in, most of their vegetation is above the surface of the soil, and so at the base of the soil, it's just a little stem sticking up, and so when water comes in, when rainfall is fairly heavy, it moves quite quickly down the slopes. There's nothing really to block it, and so it moves water and moves sediment off of the slope, and it gives far less time for percolation of water into the soil to recharge that water. So it can really change the landscape, both in terms of reducing water and also in promoting erosion. So that's another example of that. Okay, so that gives you kind of an overview of the impacts of invasive species. What are the main invasive species? Yeah, when somebody asked me here if cheatgrass is Bromus tectorum, yes, it is Bromus tectorum. So let's now look at roadsides and how we get into these, mainly propagules. We're not really talking much about short distance transport here because that would presume that invasive species were already along roadsides. So I'm looking at this as being areas that maybe don't have a lot of weeds, but when you build a road or when you reconstruct a road or do some sort of disturbance on a roadside, something can move in from long distance. And so there's various natural ways in which things can move in long distance, and there's also human-related ways. So let's talk about the natural ways. You can move in, of course, long distance by animals, what we call ectozoochoric, and that translates into ecto meaning outside, zoo meaning animal, and choric meaning space. So it's outside the animal space, and so this is in reference to the fact that seeds or propagules that may have thorns or hooks or barbs or sticky surfaces can hang on to or cling to the wool, the feathers, the fur of animals, and they can be moved fairly long distances. This isn't but I show it to you because it's the inspiration for Velcro, and it can stick to clothing, fur, anything. and move long distances. But other maybe invasive species that we find along the roadsides that do this would be things like hedge parsley, wild carrot would be similar to this. Hound's tongue, which is a major invasive species, can all have these little hooks that can move long distances on animals. And even grasses like Medusa head have these barbs and these little tiny hairs that can stick to your socks, to your pants, and to animals as well and move long distances. So these can be introduced into an area. And then ectozoochoric is inside the animal space, which basically means animals are ingesting these things and they can transport long distances, fecal materials, and drop out seeds. Something that has moved long distances in the state of California and actually throughout the western United States, primarily by bird dispersal. And there's lots of other ones that do this too. Then water can be a significant transporter of seeds as well. Most seeds do float in water. Some are really, really adapted to movement through water, and probably the one most adapted is the docks. And many of you probably are aware of curly dock and many of the other types of docks. And let me see, I'm going to show you this, my pointer here. So this has a little structure right here. It's called a callosity. It's really just a corky structure, and that corky structure is not the seed. Most people do think that's the seed. But it's just basically a floating device, and then, the wings out here are basically like sails, and they allow that plant to move quite fast on water. The seeds are here, and the seeds are actually inside everything right in there. So this is a particular example of a species that's just highly adapted to water movement. But actually, most plants seeds float on water and can move long distances. So that's one of the major avenues of seed movement, but not just seed. For example, many of us in California are well aware of giant reed or Arundo donax. Arundo donax does not even produce any viable seeds. So its dispersal is through stem fragmentation. And so when a stem breaks off and it moves downstream, each of those nodes can produce a brand new plant. So that can be a very important avenue for movement. And then wind. And I think wind is probably, at least along roadsides, rural roadsides, probably the most important. Wind, to me, is probably the most common way in which invasive species can move into roadside areas. And so when we go into forested areas and we see clear cuts and we're doing weed evaluations in these areas, almost the first species that move in that are non-native are almost always wind-blown species. It's very easy to tell. And there's lots of species that are wind dispersed, some of them really short distance wind dispersal, such as tree of heaven, and this one is Dyer's woad. But they only move a few feet with wind. They don't move that particularly far. The ones that do move far are usually members of the sunflower family, and are oftentimes thistles. There are other things like milkweed and other different types of families that also have little tufts of hair that allow them to blow for long, long distances. Something like pampas grass or jubeta grass, for example, that's cordaderia, their seeds can blow 15 miles in the wind. So they can be very long distance movement. And these things all have, a lot of the composites will have these things called pappus, which I'll show you. It's right here. Let's move this right in here. It's a structure right in here that allows it to act like a little parachute. So Canada thistle might be something like that, and bull thistle has its pappus up here, and this beautiful little pappus here on rush skeleton weed that acts like a parachute, can allow that plant to move quite long distances. And one of the bigger ones is salsify, if you know that. It's a great big bulb, maybe 3 inches in diameter, and each of these seeds can blow long distances. And prickly lettuce, which is a very, very common plant along roadsides. So, all of these little structures allow these species to blow into forested areas, open areas, roadside areas quite quickly. So those are kind of the natural means at which propagules can disperse, but obviously humans can disperse seeds long distances, and they can do that along roadsides by soil contamination, by contamination of tools, vehicles, clothing, equipment, and all these means. And in addition to just the roadside, humans can move things long distances because ornamentals can oftentimes be invasive, or you can use plants for erosion control or forage that can be invasive as well. So we're just going to focus on the ones along roadsides here and these different types of mechanisms by which you can get contaminated materials and seeds in an area. And so you may have seeds such as Italian thistle that really don't have much of a well-developed pappus, so they don't really blow in, but they can stick in the mud and on the tires or other areas of vehicles and move long distances that way. And of course, this is the main way that yellow star thistle has moved around the state. It's moved as a contaminant of hay, but also in soil. And you'll notice it does have a pappus. This is a pappus that some of the seed have right here. But this pappus really doesn't contribute to wind dispersal. It's really only there to kind of push the seed out of the seed head rather than to move it by wind. Most of the seed, 90-something% of the seed of yellow star thistle fall within 2 feet of the parent plant. So its primary means of moving long distances is not going to be by wind. It's going to be by contamination of various materials, including vehicles. And then you can get really small seed, perennial pepperweed, one of our main invasive species in the state that also primarily moves in mud, contamination with mud. So those are the different ways in which seeds and propagules can move into an area, but moving in doesn't necessarily mean they're going to become established. So to get established in a particular area, other things have to happen. And one of the main relationships between establishment of invasive species and their introduction is disturbance. Weeds just tend to like disturbance. Native vegetation, you can reduce the frequency and the intensity of your disturbance. You'll generally favor more desirable native species. When you have very high intensity disturbance that are very frequent, as occurs, for example, in agricultural areas or in urban areas, you just tend to have a lot more weedy species in there. They're ruderal species. They like disturbance, and they do very well with disturbance. So it's important to understand that relationship when we start thinking about mitigation practices, the relationship between disturbance and invasive species. So these types of really intense disturbances are very likely to lead to more rapid establishment of non-native species. So sometimes disturbances are natural. They happen all the time. Grazing, or let's say the semi-natural in the case of livestock, grazing or fire or flooding or drought, these can be natural types of disturbance. And so there are native species and, of course, non-native species that are adapted to certain levels of disturbance. But as disturbance increases through human activity, becomes more intense and more frequent, you just tend to favor more invasive species and the success of invasive species. I mean, this is the reason why they're invasive, is that they can move into disturbed areas so well. So these types of areas, for example, probably don't regularly see this level, this intensity of disturbance. So when you do disturb an area like this, you're likely not to favor the native vegetation. This is far more intense of a disturbance than they're used to. You're going to favor the non-native vegetation. So how does disturbance actually favor invasives, and what does it do that favors invasives? Well, one thing is if you look at that previous picture that I showed you, you get a much higher increase in light penetration through that canopy, and so you get increased resource availability in terms of light, but you also get increased resource availability in nutrients as well as water, because you've eliminated a lot of the vegetation, so you have more nutrients available, and you also have more water available because you've eliminated the competition by removing that. So now you've got higher light, higher nutrient, higher water availability, and the species that just really utilize those resources quickly are going to be usually your winners, and invasive species tend to do that. So they're going to be the winners in that situation. And that's occurs oftentimes around building structures, but it also occurs, of course, on roadside improvements and construction. So if we just sort of understand how it all works, you see that the margins of roads tend to be the areas that are most disturbed. This is due to construction or reconstruction, and periodic grazing, and also vegetation management, which I asked you in the question. So all of these areas tend to be the highest disturbance around these. You oftentimes get more water availability, not only because plants aren't using it, but also along roadsides when it rains, especially if you have asphalt or cement roads, but it occurs even when you don't have that. You get water running off the roads, and where does it end up? It ends up on the margins of the roads, and so plants along the margins of the roads tend to get more water than than maybe plants that are more interior from the roads. In addition, they, of course, are going to have oftentimes have higher nutrients, not only because they don't have competition, but also because many times the soil that's brought in is not native soils, and so it might have higher levels of nutrients in it. And even if you bring in other materials such as straw, it might be contaminated, or sometimes people would use erosion control species that aren't native, and they quickly get established and become a problem in those areas. So these are sort of the situations as why margins of roadsides tend to have a lot more weeds. But how do you manage that? Well, obviously, since I've already pointed out that disturbance is one of the key factors leading to establishment of invasive species, you can reduce the intensity and even the timing and frequency of the disturbance, and that's going to favor more your native vegetation than it will your invasive species. So smaller scale, less frequent, low intensity disturbances will favor more desirable species, and the opposite is true. Higher, large scale, more frequent, higher intensity disturbances are going to favor ruderal species or weedy species, in particular invasive species. So let's look at some prevention strategies. Prevention is the first line of defense, so no matter what kind of management strategy you have, it ought to start with prevention. And one thing you need to do in an area is to understand what plants are native, what plants are not native, so that you can identify and eradicate those that are weedy right from the very beginning. It's just obviously much more economical to eliminate a few weeds that just get into an area than to let them get established and then have sort of a large population with a large seed bank. So also as a matter of prevention, you want to minimize those things that promote weed germination and establishment. And as I mentioned, that's disturbance, high soil disturbance. That might require reducing traffic on a particular road, retaining some shade in an area, not allowing too much light penetration, but just enough that you need, retaining as much of the native vegetation as you can. And so, for example, you might use a loader and dump trucks instead of a grader that will leave more vegetation on the roadside. It's best to retain your original topsoil. That might have a native plant seed bank that's already endemic to that particular area. So these kinds of things can reduce contamination and can also increase native plants in that area. You definitely want to use weed-free equipment in your staging areas. This happens to be a fairly common way that new plants get introduced. In fact, in our state, diffuse knapweed and spotted knapweed are thought to have been introduced into our state when the Forest Service fights fires, and they bring in equipment from other states with contaminated soil, and this equipment then became the source of the introduction of a lot of the seed of some of these invasive species. So you need to use weed-free equipment in this. And if you're going to work on areas, you work in the areas that are non-infested first, and then move your way to the areas that are already infested if you have a gradation infested to non-infested areas. So just to show you the movement of trucks as we're building the roads. Of course, I talked about cleaning equipment, and it's important not only to clean equipment, clothing, tools, etc. before entering an area, but also before leaving an area, removing all the mud and other plant material. And if you have something that's really contaminated, you need to quarantine it so it doesn't spread propagules around. So if you can see this picture, and I hope you can see it, you can see the pants on this particular individual right in here. And you can see those pants are just absolutely loaded with seeds. And these are seeds that have probably little hooks or barbs on them, and can move. That person will move those seeds from one area to another. So it's important that you clean those, not just your equipment, but also your clothing and your shoes as well. There's various types of things people have, equipment people have that can help you clean your shoes. Spray down your equipment here, or your ATVs, or whatever it might be, to remove all of the different propagules from moving from one area to another. If you're going to use things like fibers or gravel or straw or mulch or hay or whatever it might be, fiber rolls, fills, whatever, they should be weed-free as well. This is a yellow star thistle field that I'm showing you right in here, and you can see that there's no doubt that those bales of hay have quite a bit of yellow star thistle seed in them. Gravel pits as well need to be made sure they're weed-free. They need to be treated beforehand, or whatever you need to do. And then consider chipping the local plants. I told you that that litter can be a mulch that can block the light and can prevent weed infestations. Well, using chipped material on site can also do the same thing, and that may suppress weed establishment as well. So there's a lot of different things you can do. If you're going to use and revegetate an area, it's best to use high purity, local weed-free seed to do that, so you don't introduce weeds into the area. Again, mulches, as I've mentioned before, local mulches can help prevent that, and they don't introduce new seed. And the area still needs to be inspected, though, for a couple of years to make sure that you don't have any new establishment of invasive species. If you do find something that's new, get rid of it immediately. Don't wait. It's much tougher to control any invasive species where the seed bank is already built up. Some seed banks can survive 30, 40 years in the soil. You'll be fighting them forever. So it's best to do it right away. Now, I have this as control options for rangeland, but these control options would apply for forestry, roadsides, everything else. Not all of them really apply on roadsides. The ones that really apply would mainly be the mechanical control strategies and the chemical control strategies. In mechanical, you really wouldn't use tilling very much, but mowing is a common weed control strategy along roadsides. But even other hand pulling, hoeing, other hand tools, weed whips, chainsaws for bigger plants, loppers for woodier plants, and weed wrenches for woodier plants can be used as well. Chemical is usually foliar applications, but if you're worried about drift issues, wick applications work fairly well. Wick applications are basically, they look like hockey sticks, and you put concentrated material, maybe a 33% solution in the hollow of the stick, and at the end of it, it's like a paintbrush, and it's or a roller brush, and you can just touch the plants that you want to control. Be very selective that way without damaging the native vegetation. If you have woody plants, you can use other techniques such as basal bark, touch stem ejection technique. And before you use any of these, we talk about land use considerations and objectives in all wildlands, and you'd probably want to do the same even on roadsides. The type of tool that you choose really depends upon what you need to use that area for, or what's an important part of that. If you have endangered species in the area, you might not use a broad, foliar, broad spectrum herbicide. You might use something that's much more selective. So it's what your land use is going to depend upon the type of strategy that you're going to use. So BMPs is best management practices, and the goal is to prevent the accidental introduction and spread and establishment. And so There is a manual that's available that I would like to just point out to you. It's at no charge, and I'm going to show you where you can get it. But it really was designed for land managers, but also for people who are working transportation corridors. It could be utility or roadsides. And so this might be something very useful for any of you who are in the business of trying to manage invasive species along roadsides. And it talks about planning and inventory, materials that you might need, travel and pathways, the tools and the cleaning stuff that I talked about, the clothing and waste disposal and all of that. So it can be found at the CalEPC. CalEPC stands for California Invasive Plant Council, their website. So it's called the Land Manager Prevention DMPs. And so if any of you are interested in that, you can go on that website. You can download that at no cost. So